Okay, guys, so I'm going over the second sheet of the Pythagorean theorem, so of this worksheet that we did from yesterday. So the first sheet, you should have watched the video and it should have explained to you the significance between Andy's room and Brad's room and Charlie's room and how these side links um, relate to the Pythagorean theorem. So I explained that in the video. The other point I wanted to make using this specific slide was how to use some of your tools in slides, because if we're gonna stay in this virtual format, you guys are gonna have to learn to fill some things out. So um, part of it, maybe some of you struggled with, was that it would look really small. Well, what you can do to remedy that is use your zoom in and zoom out up here on your toolbar, this little magnifying glass. So if I zoom out, that's what it looked like originally, but if I zoom in, then now I can see it a lot better, and then I can just scroll. So there were text boxes in here. You just had to type your answers. So Andy's room, if I remember right, was 9. So you should have 9 by 9. So 9x 9 is all you had to put in for your dimensions. Your process was side times side. And that also equals side squared. And so how do I make that 2 look like a square? Well, put your 2 in, highlight your 2, go up here to Format, go to Text, and go to Superscript. And now we have it squared. Okay? So then you should have found your area. The area then, 9 times 9 is 81. And the label is feet, feet squared. So I'm going to put my 2 in. I'm going to highlight it, go back up to Format, go to Text, and go to Superscript, and now it's squared. So then you should have completed these two. Charlie was 15 by 15. Again, the process is side squared. So go highlight your 2, hit Format, Text, Superscript, side squared. Then our answer is 225 feet squared. So highlight your 2, go up to Format, go to Text, and go to Superscript. I know it seems tedious, but that's what you should have done. Okay, and then here you had a text box here to write in your answer here, and same with here. Now if we go on to the next page, Part 2 says, using your graph paper, cut out 4 squares with the same dimensions as the rooms listed in each table. Let each square on the graph paper represent 1 foot. So label each piece with the name of the room. So looking at that now, so I've cut out my 4 squares. So this one here, I used each square was a foot. So this one is 8 by 8. So this side is 8. This side is 8. I have 8 squares on each side. And this is the laundry room. And the area of my laundry room would be 64 feet squared. And I'm just going to put that on there just so I know. The next one is your craft room. I sent home graph paper, so I hope that you played around with this. It makes it a lot more visual and easy to see. Each side I have 9 on each side. So my area is 81 feet squared. The next one we have here, I wonder if I can get that glare off of there, is the game room. It has a side length of 10 on each side. So our area is 100 feet squared. And our last one is the patio. And it has side lengths of 6 by 6. Oops. So it has an area of 36 feet squared. So you have your 4 manipulatives of how you can to do letter A. So letter A says, using the squares you cut out, arrange 3 rooms at a time and to see if they will meet to form a right triangle. When you've found the 3 rooms that meet to form a right triangle, record them in the example table below. When you've found 3 rooms that do not meet to form a right triangle. Record them in the non-example table below. Sketch the arrangement under each table. So first you're going to take these and you're going to try to figure out, if I put this one and this one together, does the patio work? Nope, the patio doesn't work. What if we use this one, and this one? Do we get a right triangle? Well, here's the right triangle here. Does that fit into there? No. So now we need to think of something else. What if we try the craft room and the patio? And I'm going to try this one. There, it works. So that would be one combination that worked. The craft room, the patio, and the game room. So you would come into your, here I put text boxes in here. So what room? I'm going to use the craft room. I'm going to type that in first. And the area was 81. Whoops. And another room that worked was the patio. And its area was 36 feet squared. And the third room that fit that was the game room. And its area was 100 feet squared. Okay, well, we found several combinations that didn't work. So even if you took out one of these, see clearly that doesn't work. What if we tried the laundry room and the craft room? See, that combination works. Whoops, you're not looking at what I'm looking at, I guess, huh? So if we tried laundry room, patio, and craft room, those work. So that could have been another combination you used for an example of a right triangle. When we first started, what did we use? We used the laundry room and the craft room and the game room. But I don't think they work. It doesn't work. So then that would be something, or I think we tried this. That doesn't work either. Okay, so either one of those would be in your non-example. So you can put that back here. So go over to your non-example. The room I used was the craft room. And I'm just going to put 81 over here just to save some time so you're not sitting here forever. The laundry room. And that one was how much? 64. And then the patio was 36. Okay, so that's an example of how they wouldn't work. Now to sketch it, this is where I was hoping some of you got creative. Up here on your toolbar you have shapes. So you can pick a shape. So we're going to pick a square. And so we can draw what this looks like here. So I would have a square here. And then I'm going to go back up here, click that off, pick another square here. I'm going to put it right in that corner. That one was a little bit smaller, so we would want that to look smaller. And then go back up and pick another square in shapes. And that one we want to look. So that one we're going to have to mess with a little bit, but we can move it. And obviously we're going to have to rotate it. There, just like that. Okay? So it's not perfect, but it gives us the idea of what that looks like. Now you could, when you sketch the other one, you would want to make that so it didn't match at all. So I guess if I were going to perfect this one, I would just move this a little bit closer. So we see, so here we have a perfect right triangle. Now when we do the sketch for the other one, again, you're going to go find your shape and you're going to make one that just doesn't match. So you could even copy and paste that one. If we use all three of these the same size, what does that look like? So if we have three squares the same size, it doesn't fit, right? We still get a right triangle, but we don't match up on our sides. So that would be in a sketch of a non-example one. So we're going to have to really think outside the box as far as how we make our work look. So that was one of the objectives of this assignment, not only to understand where the sides of a Pythagorean, where a squared plus b squared equals c squared comes from, because overall that's what I want you to know, but I also want you to get used to using a lot of these tools that we find in slides and some that we'll use in other programs. So I think from now on, if there's supposed to be text here, I'll just write text so you guys will know that that's where you write. And then maybe in the number spot, I'll put number maybe to help you out with that for a little bit. So when we go on, what do you notice about the area of the rooms in the example you found? What makes the different from the areas of the rooms with a non-example? So the hint was observe the sum of the two smaller rooms. So this one actually, 81 plus 36 doesn't equal 100. So we would have to go back and look at that one a little bit. And this one here where we have 81 plus 64, that doesn't equal 36. So this one, I'm wondering, I think we had to use 64. So this should be the laundry room. I should have thought that out a little further. This should be the laundry room. We would change this to 64. So 64 plus 36 equals 100. So what we notice is that when we add the sides of the triangle, they equal the side opposite the angle. So when I say that, so I'm saying this side plus this side equals the side opposite the angle. So here's our right angle. And you should have, he talked about that in the video, in the Khan Academy video. This is the side or the hypotenuse, okay? So then you should have wrote your answer in like that. Based on your observations, what can you imply about the side lengths of triangles? Well, two sides have to equal the hypotenuse is what I guess I would say. I mean, I haven't read through yours yet to see what your observations were. But based on your observations, so if this has a side length of 8 and this has a side length of 6, this has a side length of 10, what do we notice about those? Well, they're proportional, right? So side lengths need to be proportional. Your short sides equal the long side. So there was a couple of observations. Part 3, use what you've learned and observed to answer the following. So the diagram at the right shows 3 squares that meet to form a right triangle. Kate argues that the area of the largest square at the right must be 25 feet. Do you agree? So she thinks that this here is 25 feet. Well, we can easily check this. So if we know the area here is 9 foot, and 9 foot plus 16 feet is 19 plus 16, 25. Yes, so yes, she is right. Because 9 plus, 16 equals 25. Using your understanding of calculating area of squares, how could you find the side lengths of each of the squares to figure that out? Well, we know the side length of here, if the area here is 9, we know the side length has to be 3. So that would be 3 squared. The side length here would have to be 4. So we'd have 3, 4. So what's the side length of this? That's 5. Okay, again, it's proportional. So you have to find the root of the area to find side length. So again, like I said, there was 2.2 purposes for this. And it was to use, not only figure out Pythagorean theorem or start to understand Pythagorean theorem, but how to use some of your tools in slides.